Hello everyone, I am Rainier Aquino, a BSCS-2A student. Today we are tasked to make a program using stack linked list. Later I will show you my project, but first let's discuss how the program works. So what is a stack? A stack is a linear data structure that follows a particular order in which the operations are performed. The order may be LIFO, last in, first out, or FILO, first in, last out. LIFO means that the element that is inserted last comes out first, or similarly, FILO implies that the element that is inserted first comes out last. Now, let's introduce the instructions of the learning task. The student must design a Python program that will implement a stack abstract data structure using linked list. The program should determine the height of each stack and at which height the three stacks are equal. The program must ask the user for the elements of each stack. The inputs are separated by space. Once the enter key is pressed, the next prompt will be displayed accordingly. If the stacks are not equal at a given height, prompt a message. Stack heights will never be equal. Success and error message should be displayed when necessary. The program loops until user chooses not to continue or N is pressed. The output will now look like this. Okay, let's get started with the function. In this section of the video, I will explain each function and how they work in the code. First is the node class. The node class represents each node in the program. Inside, there is the init function that creates a node every time it is called. Next is the stack class. Now, the stack class contains each function of the stack, like pop or push to name a few. In stack, there is also the init function, similar to the one in the node, but this one it creates a stack rather than a node. Let's move on to the str function. Not necessarily important in the stack, but this function represents the stack as a string. It is important in printing and visualization of the stack. Next is the getSize and isEmpty functions. The getSize function, simply, it returns the size of the stack. Now the isEmpty function, this checks if the stack is empty. Now, the push function. This inserts a new element in the stack. Since it is a stack, all the new elements will be pushed at the top of the stack. The push works by first creating a new node, then links it to the current first node, moves the head pointer to this new node, and increases the stack size. If there is a push function, there is also the func function. The pop function pops or deletes the top element of the stack. It first checks if the stack is empty, then removes the first node after the head. After, it returns its value. Now, the size of the stack decreases. The getHeight function. The getHeight function returns the sum of each stack to get the height. Next, the toList function. This converts each stack into a list. This will be used later when we equalize the stacks. The equalize stacks function. This function equalizes the height of each stack. We do so by popping elements from the top until we have equalized the stack or returns an empty stack. Finally, the driver code. This contains all of the codes that are needed to interact with the user. Now that I have introduced you the stack and the codes, I will now showcase you the program. Now I will show you how to operate the program. After running the program, you will be prompted to input the elements of the stack. Let's input. After you are satisfied putting all of the elements you want to input, press enter. You will again be prompted to input another stack with its element, and again, enter if you are satisfied with your stack. And again, after you put all of the elements of the tree stack, the program will automatically compute the heights of each stack. Returns you the value in which the stack will have equal heights and the stacks with equal heights. After that, the program will ask you if you want to continue using the app. Simply type Y to continue and N to terminate the app. But what about stacks that will never be equal? Again, let's input the elements. So if the stacks will never be equal at a certain height, the program will still compute the total height but will display instead the stack heights will never be equal. Again, you will choose to continue or terminate the program. This time, let's try with bigger numbers. Now, you can continue doing this until you are satisfied. Then, after, you can close the program. I will run 2 more cases, then I will terminate the app.